we're asked to find the domain of this function, and it starts way over here by -4, but not quite at -4. And as we scan along, it ends at 7. That's a closed circle at 7. Since it's an open circle at -4, that's going to give us a parenthesis, and we put the -4 there, and it scans over. There is an opening here, but notice it's filled in, so it's going to be an x value for every x value between -4 and 7. But since the 7 is a closed circle, we put a bracket on that. The range is evaluated from the lowest y value, which is almost -2 on the y-axis, to the highest y value, which is going to be up here at 3 on the y-axis. As I scan across, I notice there are some openings, but they're filled in. So there's going to be a value from -2 on the y-axis, not included, because that's an open circle, all the way up to 1, 2, 3, because that's a closed circle. And because it's a closed circle, it gets a bracket. F of -2, when the x value is -2, the y value is 1. F of 0, when the x value is 0, the y value is 0. F of 2. So when I scroll over to 2, the x value is also 2. F of 4. So when the x value is 4, we're going to scan across till we get to 4. Notice the y value is on the x-axis, so f of 4 equals 0. F of 5, we go 1 right, and this is a little tricky. We have an open circle down here, an open circle up here, but a point. So algebraically, when f equals 5, when x equals 5, the y value is going to be at that point, 5, 1. So our value will be 1. F of 7, when x equals 7, the y value is 3. F of 6, when the x value is 6, the y value is 1, 2.5-ish. So 2.5. This is prime notation. So it's asking what the derivative at -3 on the drawing is. So when I go over to -3 on the drawing, the point is 1.5. The derivative is a slope. So the slope of the line that goes through that point is down 1 over 2, down 1 over 2. So that slope, or the derivative, or f prime of -3, is down 1 over 2. At -2, the slope is on the same line, so it's still going to be -1/2. The slope at 0. At 0, notice we have it decreasing, then increasing, but it's at a sharp edge. A sharp edge is called a cusp. And in the calculus, we are not allowed to find the derivative at a cusp, an endpoint, or a discontinuity. So that derivative does not exist. F prime of 2. So the derivative at 2, or the slope at 2, now that is the top of a circle, so it's a smooth function. It is not a sharp edge. It is not a cusp. So if we were to draw a tangent line that just barely touches that drawing, the slope of the tangent line would be 0. The slope at 5, notice at 5, it's a discontinuity, so by the rules, we are not allowed to find a derivative or a slope at a discontinuity. Limits on the graph. Limit as x approaches 0. Now, this doesn't have a positive or minus up there, so that means it's inherent that it has both. So we're going to approach 0 from both the left and right. So as I approach 0 from the left and right, notice they're going to meet up at x value 0, y value 0. So the double-sided limit is 0 for number 15. Again, there's no plus or minus up there, so that means it's going to be a double-sided limit from both the right and left. So as I approach -2 over here from the right and left, they're going to pinch in at the y value 1. I get close to y value 1. This is a right-handed limit. The limit as x approaches -4 from the right. So as I get closer and closer to this x value -4 from the right, I get closer and closer to the y value of 2. It's called a right-sided limit. Another double-sided limit as x approaches 2 from both the right and left. So I'm going to pinch in as I'm approaching x value 2 from the right and left. It gets closer and closer to the y value of 2. Left-handed limit as x approaches 5 from the left. That's what the negative means. So as I approach that value 5 from the left, I get closer and closer to the y value of -2. As x approaches 5 from the right. So there's 5. Now I'm going to approach it from the right. That gets closer and closer to the y value of +2. Now, this is where we get an understanding of what a double-sided limit can be constrained by. So as I approach 5 from the right and left, from the left, it's -2. From the right, it's +2. On the drawing, you notice it is a jump discontinuity. That's what they meant in Mean Girls when she jumped up and down and said the limit does not exist. There was a jump discontinuity there, and you're not allowed to find a limit when the left-handed limit doesn't equal the right-handed limit. How many discontinuities are on the graph from -3 to 7? So it gives us a closed interval from -3 to 7. So at -3, it is a closed circle going over to 7, and there's one discontinuity at x equals 5. So that's going to be 1. For number 22, there is one discontinuity. For number 23, how many times is f of x not differentiable on the interval from -4 to 7? Now, the rules of differentiability are you are not allowed to find a derivative at an endpoint. So that's 1. You are not allowed to find a derivative at a cusp. You are not allowed to find a derivative at a cusp. You are not allowed to find a derivative at a discontinuity. And then finally, there's another endpoint. So that's 1, 2, 3, 4, 5. There are 5 places where f of x is not differentiable. Find the average rate of change on the closed interval from -2 to 4. So at -2, I have a value here. I'm going to put a dot. At 4, I have a value here. I'm going to put a dot. And I want to calculate the slope connecting the line, connecting those 2 dots. So to get from -2 to 4, I have to go down 1 over 1, 2, 3, 4, 5, 6. So the average rate of change is the slope of -1 over 6. For number 25, we want to find the area under the curve of f of x from -2 to 0. So the area under the curve from -2 to 0 is going to be this cute little triangle. We could use the area formula, which is 1/2 base times height, or we can just count the rectangle that the triangle's inside of and then cut that in half. So there's 2 boxes, half of 2 would be 1. So it's going to be 1 by that method. Or we could just use the area formula, 1/2 the base is 2. So 1/2 of 2 times the height of 1. So that's also going to give us 1. Find the area under the curve of f of x from 0 to 4. That area is going to be a semicircle. And the area of a circle is pi r squared. So the area of a semicircle would be pi r squared divided by 2. So the radius is 2. So 2 squared would be 4 pi divided by 2. So that area of that semicircle would just be 2 pi once it's simplified. The area of that little triangle was 1. So for number 26, the area from 0 to 4 is the area of the semicircle, which is 2 pi. For 27, find the area under the curve of f of x from -2 to 4. So that means we're going to start here. We're going to find this area, which we already have is 1, all the way over to 4. That's the area of the semicircle. So all we have to do is add those areas. And that area would equal 1 plus 2 pi. Set up, but do not evaluate the difference quotient from -2 to 5. I don't even need to look at the drawing. All I need to know that this is x sub 1 and this is x sub 2. And the average rate of change is a slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I have my x sub 2 and my x sub 1, so I put the 5 down here, the -2 over there, and then we just plug that into the original. And that's it. All I had to do was set it up. So for number 29, the setup will be x sub 2 minus x sub 1 and f of 2 minus f of 0. Again, the setup, x sub 2 minus x sub 1, f of 7 minus f of 4. Now we are no longer working on a graph. We could graph this if we wanted to, but I'm not going to. I'm going to do it algebraically. So g of 1, what we're expected to do is take a 1 and plug it in to that expression, that equation, that function. And we can do that on the calculator if you want to plug in the 1. So I'm going to plug in 1 parentheses enclosed squared minus 6 times 1 plus 2. And that would equal -3 when we type that in. Now we're expected to plug in -1. So we'll try that. It'll be parentheses, -1, close parentheses, squared, minus 6, parentheses, -1, close parentheses, plus 2. And it'll evaluate it for us, and that'll give us a 9. We're asked to plug in 0, so when we plug in 0, that's going to be 0 minus 0 plus 2. G prime of x, we're expected to find the derivative. So the derivative, we'll use the power rule, 2 times 1, that's 2x. And then we subtract 1 from the exponent, so it would just be 2x. The derivative of negative 6x is negative 6. The derivative of 2, it goes away to 0. Now we're expected to plug in values to the derivative. What's g prime of 1? So that means at 1, the slope would be 2 minus 6, negative 4. At negative 1, that would be negative 2 minus 6. That slope would be negative 8. At 0, if I plug in 0, that would give me 0 minus 6. That would equal negative 6. So all we're expected to do with g prime is plug the value into the derivative. Again, when I plug in negative 2, that would be 2 times negative 1. That's negative 2 minus 6 is negative 8. Plug in 0. 0 minus 6 is negative 6. Number 38, we're going to find the limit as x approaches 1. Now, all I really have to do is what I did over here, is plug that 1 in and that'll give me what it's approaching. And it's the same as g of 1, so it would be negative 3. The limit as x approaches negative 1. Again, we're expected to plug in negative 1 to the function, and that would generate a 9. Limit as x approaches 0 is the same as plugging in 0. That would equal 2. For number 41, we're now expected to take the derivative of the derivative. So the derivative of 2x minus 6 is just 2. Is there a place for me to plug in negative 1? There isn't. So the slope at negative 1 of the second derivative is going to be 2. The slope at 0 of the second derivative is going to be 2. There's nowhere for me to plug the 0 in. 44, we're going to find the average rate of change. So I'm going to set up the slope formula. I'm going to put my x sub 2 there, my x sub 1 there. That's easy enough. It's going to be over 1. Now when I plug 1 into the function, it's going to equal negative 3. When I plug 0 into the function, it's going to equal 2. So negative 3 minus 2 equals negative 5 over 1 minus 0 is 1. So you could write that or just write negative 5 in the place where it belongs. For 45, again, the average rate of change on the closed interval from 1 to 3. We plug the 3 into x sub 2 minus x sub 1. We have to evaluate it at 3. And notice I don't have it evaluated at 3, so I actually have to plug that in. That would be 3 squared minus 6 times 3 plus 2. I can just back arrow if you want to be a little lazy. Back arrow up into your original. Delete that out and put in 3. Back arrow into the original. Delete that out and put in 3. They're asking me to plug in 3. I thought it was negative 3 for a second. So that's going to generate negative 7. So negative 7 goes on the top. I'm asked to plug in 1 to that original function. And I've already plugged in 1. That would be negative 3. So our arithmetic is going to be negative 7 plus 3 over 3 minus 1. We can do that in its entirety using the fraction button on the calculator. And we're going to type in negative 7 minus negative 3 over 3 minus 1. And the answer is negative 2. Find the average rate of change on the closed interval from negative 1 to 2. Set up my slope template. I put the 2 here, the minus 1. I plug in 2 to the original equation. I don't have that already done. So when I plug in 2, that's going to be 4 minus 12. 4 minus 12 when I plug in 2. 2 squared is 4. 6 times 2 is 12 minus 12 plus 2. So 4 minus 12 plus 2. and that gives us negative 6. Now when I plug in negative 1, I plug negative 1 in. We already plugged in negative 1. That would be 9. So negative 6 minus 9 is negative 15. Over 2 minus 1 is 3. And that would equal negative 5. Find the values of A or B such that f of x is continuous. So that means they have to be equal to one another where there's a discontinuity at 4, where the pieces meet. So what we're going to do is we're going to plug 4 into x. So we put x equals 4 in there. That would be 12 plus 2. So that would be 14. And then we're going to set that equal to where we plug 4 into x here. So 4 times 5, that would be 20 plus a. That's going to give us a equals, when I subtract 20 from both sides, negative 6. So for number 47, a equals negative 6. This one, I have 3 equations, so it's going to be a little bit more challenging. We have to set up the first 2, and we're going to set them equal to one another at x equals negative 3. So 2 times negative 3 would be negative 6 minus a equals negative 3a. When I plug in negative 3 for x, it's going to be negative 3a plus 2b. I want to bring over the a. I'm going to add a to both sides. That's going to give us negative 2a plus 2b is equal to negative 6. So we have our first equation, negative 2a plus 2b equals negative 6. Now we have to set the second 2 equations equal to one another. So we're going to plug in 3 this time to x. That would give us 3a plus 2b equals, and we're going to plug 3 into that, x equals b minus 5 times 3 is 15. We're going to rewrite this. We're going to subtract b from both sides. So that would give us 3a plus 1b equals negative 15. 3a plus 1b equals negative 15. And now we're going to use the technology to solve that. We can solve that by hand if we wanted to, but I'm going to mode 5-1 it. Mode 5-1. And I'm going to replace those zeros with the coefficients. So negative 2 equals 2 equals negative 6 equals 3 equals 1 equals negative 15 equals. So the x value is negative 3, but in this case, that would be a equals negative 3. The y value equals negative 6. In this case, that would be b equals negative 6. So those are the 2 values that make this weird piecewise function continuous. For 49, we're asked to write the equation in 3 ways. The first way is standard form. So notice this is positive. To rewrite it in standard form quickly, we put the opposite of that slope underneath the comma, and then the 3 would generate a 3x minus 4y. Now all we need to do is figure out what that equals. So we plug that 5 into 3x. So that's going to give us 15. Minus, we plug that 2 into y. So 4 times 2 is 8. So 15 minus 8 equals 7. So our equation's going to be 3x minus 4y equals 7. Our slope-intercept form, we already have the slope of 3/4. So y equals 3/4 x. And all we need to do now is figure out what the y-intercept is. So I'm going to do yin-yang to find out what my y-intercept is. I don't even have to do yang. All I have to do is the yin. So I take the 0 and I plug it in for x, and that gives us negative 4y equals 7. So if I divide both sides by negative 4, my y-intercept would be negative 7/4. I could find the y-intercept, that would be 7/3, but I don't want to confuse you any more than you need to be. The final equation is point slope form. That's going to be y minus y sub 1 equals m times x minus x sub 1. Y minus something is equal to something times x minus something else. And all we need to do is bring in these values for y, which is 2, for the slope, which is 3/4, and x would be 5. And that's my answer. I'm just going to copy it down over here to make it neater. Y minus 2 equals 3/4 times x minus 5. Thank you very much.